myself, so I expect you also hear me. It is 5 p.m. Hello and welcome and guten Abend for our session, the Unconference session, No Data Without Software. I'm here the presenter a little bit, the moderator, and I will guide you through this 1 hour session where we present some challenges, some also success stories, some ideas behind software and how software helps in research and beyond. First of all, we have, sehr gut, danke. I don't have enough hands. We have a Slido, not yet, but it will be activated later, so you can just save the QR code, and if we say now, you can vote. But first of all, okay. Yes. But I can just start with say hello to our speakers and panelists. First of all, this is Michael Gödicke, a senior professor of computer science at the University of Duisburg-Essen. He is a member of the board of directors at Paluno, the Ruhr Institute of Software Technology. His research focus is about systematic design of software development methods and component concepts for constructing software systems. Very short. Everyone has an idea about it. And he is speaker of the NFDI Cross-CS Consortium. A little applause, I would say. Say hello. Thank you, thank you. It is an interactive session, so we all have to do something. The next one is Moran Grünpeter. She was professional harpist, but is now a computer scientist. She is the head of the open science operations as a software heritage. She is also the chair of the CodeMeter Project Management Committee and is working in EOSC project fair core for EOSC. Say hello to Moran. The next person is Leila Jael Castro. She's a computer scientist specialized in semantic web, linked data, ontologies, metadata, and machine learning. She's team leader at ZBMed, Information Center for Life Science, and she is part of NFDI for Data Science and is also working in community projects as part of bioschemas, EOSC, Elixir, and the RDA. Welcome to Leila. The next one is Gabriele Tänzer. She is professor of software engineering at the Philips University Marburg. Her research focus is about software evolution and software and data quality engineering. She is one of the leaders of the Conda project on continuous quality management of dynamic research data on objects of material culture. Say hello to Gabriele. And last but not least, it's me. I'm Jan Bernot. I am team leader of a subgroup infrastructure at the chair of Professor Dr. Ulrike Lucke at the University of Potsdam. I'm also a computer scientist. My main research interest is in research software management, but also research software engineering, and also to support science communication. I'm part of the NFDI Cross-CS Consortium and also PhD candidate. Hello. So now I will introduce this session. We have 4 main slots. The introduction we already have done here. Now we have 3 short introductory talks where we can have this ground theories of this topic. After that, we want to get in touch with you. For for example, with polls, but you can also ask questions. And afterwards, we have a short discussion with the panelists and speakers. So let's start, Michael.
Thank you very much. I hope you can hear me. I cannot speak very loudly because my voice is a little bit affected. And I will briefly introduce you to the role of software in data-driven scientific processes and and also kind of addressing the claim a little bit we put in the title of this Unconference session. You see here in the right corner that we have a data-driven process like finding ideas. Sorry for the German here, but you make it up yourself. You plan the research, you do the data extraction or simulation, stuff like that. You analyze the data. You find some pattern which you are looking for, maybe, or you find some pattern which you don't look for in the data, and then you make sure that your findings have decent quality, that you can actually make a publication out of it or publish data, and then go into the publication processes. That's the normal rough outline of a research data cycle, in reality it's much more complicated and involved, but that's the theory, so to say. And the thing is that I mean, we said in the title no data without software. So you lose all your data, which is the most important asset. So people this morning told about us that the data is the oil or the gold of the 21st century. But why losing it? I mean, because the pink arrows here. So you see those symbols here. Kind of relate to the search data cycle. And the pink arrows there, they all mean software is involved. For example, extracting the data from your measurement is done via software. In many cases, even proprietary software. But you also have simulation. So this square with these pins is meant to be in silicio experiments or simulation experiments. So you generate data quite a lot in weather simulation or something similar, or you just measure data from persons in an HCI experiment, for example. So that creates raw data by using software to extract the data from your measurement or your data generation. The raw data is not usable in any way. You have to purge it, you have to find measurement errors, outliers, stuff like that. You come up then in a second stage with kind of tabular video or curated software in some sense. Again, you use software for that. You write your own scripts and stuff like that, or you use a package for that, or you use machine learning tools, whatever. It's the way things are done these days because the raw data sets are huge and you can't do it manually. So you need software here. And then in the end, you want to present your results once you have analyzed the data of the purged data. Again, this is also done by software packages. Normally you use quite complicated statistical methods, for example, in R or SPSS or whatever. And in the end, you rely very much on a chain of software components in your research. So that's, I think, in many cases this is true. Maybe it differs from discipline to discipline or experiment to experiment, but in some way or the other, you really depend on pieces of software you either have written yourself or use from somebody else, or depend on maybe even proprietary software as a package, for example. And guess what happens if there is some error in that? Okay, this is a kind of infamous example where so the dead fish also showed brain activity. That's the example here. I was told not to use the picture from Ars Technica. You find this paper, and this is really important to see that about 40,000 publications use these packages and they created false results, so to say. And it was quite difficult to see how to deal with that situation, because quite a number of findings were reported on that. In the end, you need a good way to use software. For that kind of thing, you need competences to do this. And this is a short, brief overview of what kind of elements you use in your software packages. Software package should be fair in the sense that they support the FAIR principles. I don't repeat those. But it's also important to relate to the provenance of software, the quality, that's really an important thing. Identifiers, authors, and so on. Also, this is always embedded into various pieces of other artifacts that needs to be done. And important, it must be machine actionable. So we have concepts for that, but we talk about that maybe later. Thank you very much about that. Thank you.
Yeah, hello everybody. My name is Gabriele Tenzer, and I want to talk now about developing software for the long term. Oh, sorry. I have to stand here. Sorry. Yeah. First of all, I want like to ask you, have you ever thought how long software is you are using? So, for example, how old is Windows? How old is Excel? How old is the R software? Any ideas? Yeah, and even more. So Windows is from 1985, so 30 years old, more or less, a little bit less. 40 years, oh sorry. And R is from 1993, so it's also quite old. Yeah. So so these are just some examples that you see. Software is really something that is developed on the long term. So software development is a continuous process. And what does it mean? So the first release was for R, for example, 30 or more than 30 years ago. But then the real work starts. Yeah? So then the software is developed further. And this means errors occur once the users are using the software. Errors occur, they report on that. And then maybe new requirements come up from the users. They want to have more, more functionality in the software. And then new versions of the software come up. Maybe also the environment of the software is changing, so meaning that the underlying software components change. And then the software has to be changed as well. Yeah? And so looking at software updates, and this is what is meant, yeah? So long-living software means that you also have to update your software from time to time. If you use a software product that is developed professionally, software update is usually not a big deal. Yeah, so you do it regularly. You are forced to do it, more or less forced to do it regularly. But coming to in-house software that is written in your institution, is written by yourself, some research software, it is usually not regularly updated, but it can also run, out of time, so to say. Yeah, and then something happens which is called software ages. And now you ask yourself, oh, software is virtual, why can it age? And there was this famous computer scientist, David Parnas, and he said 1994, programs like people get old, we can't prevent aging, but we can understand its causes, take steps to limit its effects, temporarily reverse some of the damage it has caused, and prepare for the day when the software is no longer viable. Yeah. People don't want to get old, huh? software should not get old. So why is it getting old? And it can happen that the software is not evolved enough. Yeah? So there are some requirements from the users, and these requirements, these additional requirements, are not built into the software. Or they are built in, but the software is less reliable in the end, and the code is less clean. Yeah? And this brings me to software quality, and the statement that software evolution is easier if the software is of good quality. And good quality means, that there's a test suite for the software, at least for the core functionality, that there's a good documentation, not only for the users, but also for the developers, that the code is well structured, or clean code, maybe you know clean code, and easy to read, and a lot more. And there's an ISO standard on software quality saying what it means that software is good software. Yeah? And it has a lot of different aspects, and it also depends on the software which of these quality aspects are most important. Sometimes it's correctness, sometimes it's usability of the software, good usability or good learnability, something like that. Okay. And with this statement, I hand over to Maureen.
Okay, thank you very much, Gabi. Thank you, Jan, Michael, and Leila for inviting me to this panel. I'm not going to present myself because Jan has done a wonderful job doing this, okay? So I'm going to keep this 1 minute and go straightly here because I can talk 3 hours on software heritage, on software identifiers, and on software metadata, and I don't have 3 hours. I have only 5 minutes, and now maybe 4:45. So what I'm going to show you now is that software, research software, is not created in isolation. There's much more than just the research software. And on the slide, you see the diagram by Konrad Hinsen, which is called the software collapse. So it's doomsday for software. And as Gabi said, software ages. But even if the software, the research software ages, the other layers there, the domain-specific tools, the scientific infrastructure, the operating systems, and even the everything is aging and can make the whole building collapse. And we do have scholarly repositories like Zenodo to keep the upper layers, and we need something to keep all the rest. And for that, we have software heritage. So let me show your hand. Who in the room know software heritage? Amazing! Wow! I will just keep your hands up. Keep your hands up. Can someone take a picture of this? Yes. Keep. Yeah. Thank you, Anu. Thank you. Perfect. Now keep your hand raised if you ever used software heritage to archive software, to search for software, to archive not your software, someone else's software. Excellent. Now bring your hands down. Now another question. Who here knows Zenodo? Yes, I think that everyone. Someone that doesn't know Zenodo, it's really bad. Who here uses Zenodo, not only for software? I think that you have all your hands raised. Excellent, great. Because I have a very big announcement. I'm not going to do it now, but a very big announcement. Yeah. Exciting, right? Okay, next. So, in 2020 was published the Scholarly Infrastructure for Research Software report by the EOSC task force. Some of maybe the authors are here. Defining the fact that archive, reference, describe, and cite software is important for the whole scholarly ecosystem. And a set of recommendations was published. Here are only the short-term recommendations that we'll discuss today. Again, I have only 5 minutes. One of these is strengthening interconnection between infrastructure. So you see the connections on the diagram between aggregators and software heritage, but also other interconnections in this space, the scholarly ecosystem, knowing that software heritage is not catering only scholarly items, but also industry, public administration, and cultural heritage. Other recommendations are for metadata standardization and the generalization of the usage of the PIDs, extrinsic and intrinsic, and the SWID. So with your hand, who knows what's a SWID? Yes, less hands now. A SWID is a software hash identifier. I'm not going to talk about that today. So what we have been doing in the two projects I'm part of, so I didn't present myself, so I didn't say it, but I'm a work package lead in the FAIR Call for EOS project and task lead in the FAIR Impact project. And this project, we are implementing the vision of the CERS report, which is a community-driven vision, creating these connections. And so for the minute, I have 1 minute. For this minute, I want to say that today we've released a blog post saying that Zenodo has deployed the connector between Zenodo and software heritage. So now when you deposit a software artifact in Zenodo, it is also in software heritage. And we are building these connections with the other infrastructures, such as the Dance Dataverse instance, DAX-Tool, and Episciences for publishers. So to tell you the truth, DAX-Tool and Episciences also have deployed it in production, but it's not breaking news. But for this breaking news, I would like for a clap of hand, if you can, for Alex, that's back there, is the Zenodo service manager. I'm sorry, I did that, Alex. Thank you for doing that. I'm not going to read the rest, but I'm going to do a call to action, because software prioritization requires more than just me. I know I have 0 minutes, but I will say it. It requires a global and coordinated effort to have mutualization, sustainability, curation, recognition, and also to push forward open by default. And now, we are moving to the questions part. So thank you for having me here on the panel, and it is your turn to say some things.
Yeah, thank you very much. And thank you also for these well-timed presentations. Now we come to the next point where we want to have a little interaction with you. So we have here a polling which will be soon shown with the QR code again. We have 3 main questions in the first 3 slides about your research discipline, about the role with research software, and about challenges with research software. And at the point when Moran will activate it, you can poll on research disciplines. And after these polls, you have also the possibility to ask questions in the Q&A panel and vote for the best question, and we can answer this on the panel discussion. Yeah. Thank you very much.
The slide, if you don't have it, you have it there.
Exactly, and while you are voting, we can talk a little bit. And I have a question for the first panelist, and later you can also come to us on stage. Michael and Gabi, you are both professors for software engineering, and I think from outer world it looks like that you're doing the same. Software engineering looks very, very similar from outside, but from inside there are differences. Can you guide us a little bit through where are the differences in your research activities, and maybe also where are some overlaps?
Okay. Okay, my work is very much centered about software architecture and application of software architecture to various domains. So we do a little bit on work on e-assessment, have created a service as well. In terms of software engineering, I would like to see more standardization in terms of structuring complex software systems and find also reference architectures. For example, we are using the notion of reference architecture in our consortium, NFDI Cross-CS, for designing the research data management container, which is an abstraction to store research data in computer science, and that's quite a diverse area, and have to find these abstractions, and that's a nice challenge for software architecture.
Okay, one of my main research questions is to develop, to make the software development easier and faster, and the idea is to take the software development on a higher abstraction level, and to develop software in a model-driven way. And this means that we use models to describe the domain-specific parts of the software, and then use code generators to create all the code that is the usual one, so to say. And models can also be used to describe software architecture, so there's some overlapping with Michael's research. And what we also hope to receive or to achieve is to get better software with this approach, to let the code generators generate code, generate the software, and to the generators are mature enough so that the software in the end has better quality. And this brings me to the second part of my research, and this is software quality. So all the methods, techniques, and tools to develop better software. Yeah. And mainly we are now in testing and more semantic ways of testing. Maybe you have heard of mutation testing, but I don't know if I should go into details here.
I think we don't have the time for this, but thank you. Now we have the first results.
I've changed the slide. Just a second. Yeah. First results. Go ahead.
Do you want to say something? Or?
No, I see that there's a lot of different domains. It's really very interesting. We'll have a good takeaway message at the end. I do suggest to move to the next question.
Yeah, I expected also more computer scientists, because computer scientists talk to computer scientists always, and no one cares. But the next question...
But we do talk together.
We care now, and we see different people care about. This is perfect. And the next one is about the roles.
Yes. So the question is now on your phone, or your computer, in your daily work, what activities do you perform to work with research software? So you can create, but you can also say reuse, maintain, participate in working groups related to metadata and standards, decide what research software will be created, decide what research software libraries will be used, train researchers. So I think I see that the majority is in the last part for the training users. Well, oh, it changes so quickly. Let's wait a minute.
It's a head-to-head, yeah.
Head-to-head.
So just to talk a little bit about this aspect, Leila, how would you define your roles in your activities at ZBMeet?
So I chose some of those. The first one that I chose was the one related with metadata, that I'm actually very, very happy to see is winning the competition today. I am actually surprised about it. Also, deciding what is the research software that will be created and how it will be created, so which libraries will be used. And in general terms, I kind of provide coordination and guidelines on the different aspects for the research software engineers in the team to actually create good software with good quality, with good metadata, and well, this is what we try at least.
Thank you. do you want something to add from your
Yeah, I
perspective?
will add a little bit. So I just wanted to share some information because from my perspective, on the creating software side, there was some suggestion of taxonomies to identify which role are you having when you create software. And the credit ontology, which is excellent, has only one role for software called software. In the yes, absolutely. And for our institution, INRIA, which is, well, we're mostly computer scientists, there was a work done for crediting software authors with these 7 types of roles that we try to integrate into the code meta vocabulary. So now in the version 3 of the vocabulary, you have the roles. You can provide a role for a software author. And in the code meta generator, so I didn't say that because I didn't have time, so I'm going to take this time. Yes, Jan. I'm going to take this time to talk about code meta. There's a code meta generator that you can use to create your code meta files. And even there, in this tool, you can now, that's new, use an author roles. So I'm really basing my response on the one here creating research software. And I see that only 35% here are creating software, but I do know that all of you depend on software. So let's take care of our software.
Yeah, thank you very much. And
Jan,
yeah.
I want to add something very quickly.
Yes.
If there is anyone in the audience, or you have a friend of a friend who happens to work with the citation file, please really push them to also adopt the roles, because we need them in the citation file.
I work with citation files, but thank you. Okay. I think you see who the winner is, and we also commented it. The metadata standards, or groups work on metadata and standards. And in the end, at the end are the maintainers. Last but not least, I would say. Okay, so now we switch to the third question.
A tough one. Do you want to read it, or should I read it? I read it, yes. Yeah. What is the greatest challenge you face in your research activities, particularly in relation to research software? So we have a few challenges in mind. Please feel free to tell us if you want to take the mic and share another challenge. So the challenges are how to use a standard software product, second one, how to develop my own software, how to assess the quality of my software, how to make my software fair, how to select the right license for my software, how to preserve my software, very important one, and how to reuse or rerun someone else's software.
It's really attempting to just watch these bars and see which one is rising and which one is falling.
They're moving so quickly.
Yeah.
We have only 45 responders, which means that we are missing 20 responders. Please give me your challenge.
The remote, so we want to get to 100 because we also have remote participants.
Is there someone to want to change a challenge for the?
Oh,
yes?
I have
We have a microphone there, and I can.
Oh, he's going.
Thank you. Carol Goebel from Elixir and Software Sustainability Institute, and reviewer of Moran's excellent deliverables from EOSC, all the things she's in, actually. What's missing here is I want sustaining my software, not preserving it. I don't want to preserve my software. I want to sustain it and evolve it. And so for me, the biggest challenge is how do I sustain software which is between projects through a project-orientated funding scheme. So can I add that one to your list?
Yes, absolutely. I think that we can add it.
Yeah, thank you very much. I've written it down here. Yeah. depending on sustaining, there is something in FDI Cross CS I know we are working on.
Yeah. I think this is a perfect comment to the work, and it's quite important. So I mean, when we wrote preserving, that meant sustaining actually. So I would say that's our inability to use English in a proper word. I'm sorry about that. It has various aspects. I mean, one is, as you said, going from version to version, from one project to the next project, to publish it for the community, and then keep it there alive and in a sustainable way. That's quite important. In a sense, to preserve software with the data, we have developed the container concept. Others have developed container concept as well, but I think looking at all these data-oriented approaches, also presented these today, it's really important in the sense to reuse or even reproduce your results with the data you have. It is actually important to preserve the software in the version you have done in your research 10 years ago or something like that. So that's preservation and not sustaining. And this is also important to have reusability and reproducibility for your research data you developed, measured, or simulated, or whatsoever 10 years or 15 years ago or so. So two aspects of that, and very good that you pointed that. We have concepts for one, and the other thing is a kind of general software engineering approach to evolution, which is also part of the work of Gabi and me, but it's also a challenge for funding. So, and also for careers. So the research software engineers doing that need to be addressed in a proper way by citation and addressing their role. Although maintenance is going to be less popular, or what is? There was. Yeah. Okay. Okay, so I stop here. It's really maintenance is maybe kind of boring work, but it's way beyond thinking of importance for our work.
I would like to add a few words to that, because when you talk about software sustaining, then this means that you want to further develop your software, and this means that your software has to have a certain quality. Otherwise, it's really difficult to further develop it. And so software quality is really a must, and it's more than fair. Yeah? So fair is finding the software and reusing it. But software quality means also that the software is correct, that the software is reliable, that the software is efficient and mature enough, that the software is usable, that it is easy to learn, and so on and so on. So it's a lot of different aspects that come around with software quality. Yeah. So making the software fair is the first step, but it's not the last one. This is something I wanted to add.
Yeah, thank you for this excellent remark, I would say, and also a little bit question. Do we want to say something about how to reuse it, the software, the first challenge? And
sure.
it's also a little bit of sustainment, but
absolutely, I can take that one. So I'm very happy to see it's a challenge, because it is a challenge for us too. We provide an infrastructure to archive source code, but it doesn't mean that this archived source code can be rerun or reused, because the reuse part is depending on the license that's on the software, and the rerun part depends on the documentation and kind of the full stack. So I showed you the stack. You need to, well, you or a policymaker should take care of the stack. So how do we do that? So it comes back to sustainability. It's not just sustainability of the research software, which has maybe a lot of very quality software, very well written, and does what it should be in the experiment. If I can't reproduce that, that would be a challenge because I don't have all the stack, I don't have all the infrastructure that's with this package. So I would say that I agree with this challenge, and there are some projects that are answering that, solving that. We have the GUIX operating system. I don't know if you know them, GUIX. And they rely on SWIDs, on software hash identifiers for the operating system. So you're not using a stack that can't be reproduced. But it's a challenge. It's still a challenge. Yep.
But thank you. But also reusing software is also about metadata, how we find it, how we can reuse it in a certain environment. Isn't it your topic? I'm really good at asking questions.
Yeah, so metadata and the microphone came to me. Yes, reusability is part of what we want to address with metadata. But we need to be careful. Having good metadata, having metadata that it is aligned with FAIR doesn't make the software reusable magically. So we need to be careful in there. It's just like the initial steps, and it goes with what Gabby said. We start with that, but we don't stop with it. We continue building further. So for reusability, I would say that the metadata can give you an initial idea on how reusable your software is. It could give you also means to connect your software, your libraries, through workflows in automatic ways. And this is very important. We need to make the metadata really matching actionable, because the metadata should be meant by humans, but also by machines. And the more matching actionable it is, then the more automated pipelines we can use with that one. And with those, we can go one step further to these, let's going to connect things automatically.
Thank you very much. This aligns perfect to a question in the Q&A tab. Do you want to just read it out?
Let me see what we have here. So we have more than what I've shown you. Okay, so I'm going to ask the question. Pick one. Do we have votes on that? Can you see the questions on the QA? You don't see the questions? Okay. So absolutely. Okay. One question we had is, how can good software management be integrated into EOSC? Ooh.
Good question. Nobody at the panel can answer that. That's kind of political thing here, I would say. That this was asked this morning, how the users of EOSC can be involved in this work. And my feeling is, looking at the artifacts and you can go to the EOSC EU node already and look up what is contained in there, and that's very much either service or data. And there's the other thing. So I would like to see more of software in the other thing. The other thing contains also antenna electronics and stuff like that. So that's different from software. But maybe others have opinions about that.
Yeah, thanks. It's Fodosopoulos from CERT. And incidentally, because the question very well aligns to the project that is actually running called EVERS. And the main goal of EVERS is actually to promote research software excellence and research software quality, including aspects around research software quality that Gabi already mentioned, that it is critical to include best practices, services that support that, and including also aspects like software management. And I am absolutely in favor of not having software somewhere hidden like under services or other. It needs to be explicitly stated that we need to focus not just on data, but also on software. It's a first-class citizen in science, and we should make it so. Okay. But in terms of existing efforts, I'm very happy to say that there is at least one, and hopefully we'll have something concrete out of it.
I just want to back up Votis because he's very modest. That project has every one of the science clusters in Europe in it. So the science clusters for PANOSC, for photon, for biosciences, for all of life sciences, for earth sciences, all of them are in this one project, sharing how do they do software quality. So he's very modest, so I'll brag for him.
Thank you very much. Can you move the microphone? Oh, sorry, there's an... Yeah.
To add that with regards to software management, together with Elixir and with the NFDI for data science, we are already doing a little bit in there. We have the software management wizard. It's not a replacement of the project management. We need to make sure that this distinction is understood. But we are already working in software management plans. And we are working on matching actionability on software management plans as well. There is already a wizard that kinds of grew from a data management plan that was adapted for the software management plans. Particularly for the case of Germany, we will be working with the research data management organizer.
Thank you very much. There's another question.
Well, no, so I'm following up on this comment about services and software and their visibility in EOSC. Kevin Ashley from the Digital Creation Centre. I think one of the things we mustn't lose sight of is often there's a strong connection between those two things. It's very common in our community for people to build open software projects and for others, or the same people are building them, to also offer services based on that open software. So you can choose to pay somebody else to run something for you and consume that as a service, or instead you can say, no, I want that software and I'm going to run it locally because we think we have the capabilities to do that. That's not at all unusual in this domain, and yet I think EOS's current vision of it sees these things as so separate that it's not making that connection explicit, and that's harming, I think, sustainability of lots of these things, because that route of building services on top of open software is definitely a way to ensure that long-term sustainability.
Yeah, thank you very much. Okay. Then we have the next.
The next is, there's no next. The next is the QA. I can't show the QA. Can we show the QA? I don't know if we can show the QA. No, but I can ask. Yeah, there was a question here. No.
No question. Okay.
There. Okay.
Okay, there is a question.
Sorry to be late. One of my challenges is that software is not only as it is in an environment. So we need compilers, we need infrastructure for the software to be operational. For example, if we are measuring with an instrument, there's an SPSS system with software on it. Even worse, if there's MATLAB discontinued in the university, what you are doing afterwards. So this kind of challenges, how to tackle these. So software is more than the code.
Yeah, that's one challenge we picked up in our consortium, NFDI Cross-CS, and they have developed this notion of a research data management container, which exactly preserves, in the very sense of the word, the environment, including the Python version, the libraries of PyPy, whatever you choose to use, and store that in a time capsule. So that shouldn't change because time capsule is so, and you can open that time capsule 5 years later and execute it in a reusable execution environment in order to see, has this everything worked 5 years ago? Is it still valid? Make own reuse of the data and check whether the claims of the paper or whatever is published or the data is valid actually. So that's one aim we have, and we are not in a position to say we have accomplished the goal, but we are on a very good track to actually do this. Yeah. But that's one approach. I mean, maybe there are other approaches as well. And what we want to come up with is an architecture which survives the actual technologies we use currently, like so Docker and stuff like that. So for that kind of thing.
Yeah, thank you very much for this comment, and also to the look inside the consortium, NFVI Cross CS. I think we are not yet in the end. We can maybe have one little question.
Yeah, we can. We have a lot actually, but I will choose for you. Who has ownership of research software?
This is a tricky one. This is a tricky one. Who wants to start with a tricky question?
Should I? Should I start?
Yeah, perfect. Yeah, ask yourself. Yeah.
Okay, so it depends where you develop it. If you develop it in an institution, the institution should tell you what's the ownership of the software. And you should ask, if you're a researcher, you should ask to have it open source, and you should ask for the license that you are most comfortable with. But the institution has the ownership of that research software. Now, of course, a lot of open source software is created and you don't know that who the owner is. But when you can take ownership, being an author and an owner, that's something to negotiate with the institution or university. Yeah.
Thank you.
I would say also that ownership has at least 3 kind of variants: the copyright, the intellectual property, and the license. So those are 3 different levels that mean different things, and some of them are related to law. So you need to make sure that you understand the differences. And for that, it's very important, research software engineers and researchers who develop software need help from other departments in the institution, and also help from let's call them sections, working groups, these that work with the ethical, legal, social aspects, because they apply to software. So it's very important to take them into account as well.
Thank you very much. We don't have the time to have another question, but we can change the screen and we have a collaborative document where you can add everything you want to say. Ask questions, add comments, maybe leave a note here. You can also, of course, email us. But here's a document where everyone can work together on it, and we can take this as a kind of homework. I mean, we want to have to do something. We don't know what we want to do with our time, but it's a good opportunity to have here a reach out when you say, okay, this preservation or this sustaining, we want to add at the further level, or we want to have that explained a little bit more. You can add it here, and we try to help you with that. So coming to an end, we want to have one summarizing sentence, a condensed sentence from every panelist and speaker about the session, No Data Without Software. Leila, do you want to start? You have the microphone.
So I will start. So I'm getting something from this session and from the different questions, and is that there is no data without software, and there is no software without the software environment. If we want to make it reusable, if we want to make it sustainable, we need all the different bits that are related to the software. The software is not in isolation, as someone mentioned. So this is my takeaway from this session.
My takeaway is that it's quite diverse. I mean, we saw the disciplines at the beginning. So as you said, so not only computer science speak to computer scientists, but every kind of discipline is now involved. This matches to other experience talking to postdocs of a colleague who asked who has done no piece of software in his or her research. And nobody showed up. So everybody has to do little pieces of software. So no science available without software, and no research data as well. And that's a huge challenge for software engineering and dissemination of software engineering concepts, and also to get the requirements from the field back to software engineering. So it's a bilateral relationship for us.
Yeah, we had this little discussion about software preservation and software sustainability. And as Michael pointed out, software can be preserved in a time capsule, and you are working on this in NFDI. Yeah. And software sustainability means that the software is further developed, is adapted to the environment, and new requirements of the users are taken in, and so on. And for that, you need good software quality.
Thank you.
I can use that. You don't need to give me that. Yeah, thanks. Well, what's my takeaway from this session? Actually, I wanted to recall my call of action to work together, but I do see that there's more interest for software than I've anticipated. So I'm happy to see that. And we need to continue this line. We need to promote software and engage between projects, between clusters, and between disciplines, to have software on the front stage as a first-class citizen, so that it is preserved and the full stack is ready to be sustained.
So, thank you very much for attending this session. Thank you very much for the speakers and panelists here having with me this session. I want to have a warm applause for everyone, please, now. Thank you. These are a summary of all institutions and projects, not all institutions, institutions and projects working together for this session. I think we had a wonderful time before, having a common ground together. Thanks for voting this session also in this little sparse spots to highlight software a little bit more in the EOSC environment, but also in the research environment. And I have one thing to say. Everything is about... Ich mach's jetzt. Ja. We have a dinner at 7 p.m. afterwards, so you have now 1 hour break after this session, but then come back to the dinner at the Hofbräu Wirtshaus Berlin. I think you can see here everything you need. See another slide. Do not forget to wear your badge. So, thank you.